So we're live, right?
One second. Yeah, we're done.
Sure, great. Uh,
Yeah, let's start. 1 second.
sure.
Yeah, so hey everyone, a very warm welcome to Full Stack Squad Conference Day 2 powered by Ad Company. And I hope you all are enjoying and having fun at conference, capturing your favorite moments, posting it on social media and tagging us with hashtag FSS. Yeah, so in the previous session, we saw why Python is the developer's most chosen language. And obviously, I guess we all know the answer to it. We learned that Django is a web framework, and Shant and Vignesh helped us to understand how we can use it to build amazing products. So, to move forward in today's agenda, get up your excitement and welcome Niti Gupta. Niti is currently software engineer 2 at Microsoft, and she has 5 years of industry experience and has been involved with designing, building, and scaling microservices. She is currently exploring big data technologies and working on Hadoop and HDInsight. And today she is here to share her insights about Azure HDInsight. So, with no further delay and too much to learn ahead, let's welcome Niti Gupta. Over to you, Niti.
Hi everyone. So I'll be talking about getting started with Hadoop as well as Azure HDInsight. I'll share my screen now. Swati, can we put this here?
Yes, 1 second. Yeah, it's done.
Great. Let me just check the control. Yeah. So today's agenda is getting started with Hadoop and Azure HDInsight. Uh, Talking about myself, my name is Niti Gupta. As Swati has already told you, I'm working with Microsoft as an SDE2. I am a keen coder and I'm currently working with big data technology, Hadoop, Spark, Scala. Before exploring big data, I was working on building microservices and I've written services and algorithms for scheduling and priority queuing. You can feel free to reach out to me on Twitter or my LinkedIn for any queries or a general chit chat. So here are my Twitter profile and my LinkedIn profile. So the outline for today's session is going to be what is big data, why Hadoop, what is Azure HD Insight, why HD Insight, scenarios where you can use HD Insight, and how can you get started. The how can you get started part is the demo, which I have two of the demos where we can create cluster and see how to get started with Hadoop. So starting with a few fun facts. So today, every human created about 1.7 MB of data per second in 2020. WhatsApp users exchange up to 65 billion text messages daily. Every 2 days, we create as much information as we did from the beginning of time until 2003. And my favorite amongst all of these is if you burned all of the data created in just one day onto DVDs, you could stack them on top of each other and reach the moon twice. So now we know how tremendous data is. Data is essentially money for us today. Coming to that, we'll talk about what is big data. Big data is a collection of data that is huge in volume and growing exponentially with time. There are four Vedas of big data, four V's as we call them. First is the volume. Volume means generally the amount of data. It can be terabytes, petabytes, exabytes, and going forward, so on. An example would be the number of credit card transactions in a single day in a country like India. That's the volume of data we are talking about. Then the velocity. The velocity refers to the speed with which the data gets generated. Since the speed is so high, we need the processing capabilities and distinct processing techniques for to handle that speed of data. An example would be the Twitter posts or the Facebook messages in a single day that happen. That is the velocity of data we are talking. Then the variety of data comes with the different sources and the different types of data. It can be structured, semi-structured, or unstructured data. An example would be the CCTV audio and video files generated from a locality from different locations. So that can be a varied amount of data. And then veracity. Veracity is the uncertainty that lies with the data. Since the data is so huge, we do not know which data is the valuable data, which data is the unvaluable data, and we have all the data together. So, for example, a medical experiment or a trial, the data collected for that, there is a lot of veracity involving data there. So, now we know what big data is essentially. Now, what is Hadoop? So, in a general traditional approach, there is a centralized system and there is a database, and the centralized system takes care of the processing, which is good to handle small amounts of data. But the big data that we're talking about, generating 1.7 MB of data per second by each and every person on earth, that data is not scalable from a traditional approach. So that is why we need a distributed system. So Google in early 2000s came up with a solution where they published a paper on the map reduce algorithm. What they do is they break one problem into smaller tasks, and each task is given to one computer. The computers parallelly process those tasks and aggregate the result, which is called the map reduce problem and map reduce algorithm. The same person who published the paper, one of the person do cutting, his team developed the open source project called Hadoop near about after a few years of that paper publishing, and gradually it gained a lot of tremendous popularity in time. So today Hadoop is almost used by all the organizations who are working on this amount of data, which is essentially almost everyone in the industry. So there is a small timeline which we can see early 2000s when the paper was published by Google, and then in the mid 2000 to 2010, it Hadoop started gaining popularity, but around 2008 2009, it was one of the very highly used frameworks. And today there are, I mean, it is used, and the version in around 2000s was 1, and now the major version is 3, and we are still it is still being developed, and a lot of developments are being made. Now, to discover Hadoop, as we have already discussed, Hadoop is an open source software framework for storing data and running applications on clusters of low cost hardware. Commodity hardware is low cost hardware. We don't need expensive machines for running Hadoop. So that's why it's very efficient. There are three big things that come with it: massive storage, enormous processing power, and the parallelization of tasks that happen for the processing. This is a brief architecture. We'll be discussing about the major components in this architecture. So there are the three things in pink are the ones which are the core components of Hadoop. MapReduce is the compute of Hadoop, which is the processing capability of Hadoop. Yarn is also the compute of Hadoop, which is a resource manager and a job scheduler. And HDFS is the storage part of Hadoop, which is the file storage system, distributed file storage system. Apart from that, there's Zookeeper. Zookeeper is a distributed configuration service, a synchronization service, and a naming registry. So it takes care of the configuration and maintains the session information with it. Uzi is a part of Yarn, so we need not discuss in depth about it. Uzi is also a job scheduler, which is a component of Yarn itself. Then Apache Ambari is the UI component, which is the UI dashboard, which helps us visualizing what our Hadoop cluster looks like. Apache Storm is another integrated component, which is for the real-time event processing. So we will discuss more about the three pink components now. So the core components of Hadoop are HDFS and Yarn. So HDFS is the Hadoop distributed file system, which is the storage system which allows us to process and dump any kind of data that we have. It can be structured, unstructured, as well as semi-structured. Yarn is yet another resource negotiator. It is a job scheduler and a resource manager. It is for the processing and allows parallel processing of the data that is stored by the HDFS. Talking about HDFS, so HDFS is a distributed file system. It is actually based on GFS, which is the Google file system, and it runs on commodity hardware, as we discussed, low cost hardware. HDFS is highly fault tolerance and has high throughput access to application data. It is suitable for all the applications having large data sets. So HDFS follows a master slave architecture. The master nodes are the name nodes and the slave nodes are the data nodes. So each name node will contain the metadata of the data, which is, for example, the size of the file, the permissions, the hierarchy, the location of the blocks, all of the metadata associated with the actual data. It is used to manage the data nodes. It sends the blocks to the data nodes, and the data nodes are the ones which have the actual data with them. So it's a one-to-many relationship. Name node will be the master, and there will be multiple data nodes which will be processing all the data parallelly. All the read and write requests actually happen on the data node. The name node is managing and monitoring the data nodes and receives all the heartbeats from the data nodes. Similarly, Yarn is also a master slave architecture. Yarn's main job is to schedule all the jobs that come to it from a client. So for example, if I get any request that I need to process these applications, these jobs, Yarn will get that request. Yarn will forward it to its node managers parallelly, which will execute the blocks of request. So resource manager is our master here, and node manager is a slave. Each node manager is basically sitting on the data node we saw in HDFS. So each data node is the HDFS part, and the node manager is sitting on the data node, which is actually taking care of the execution of the job, execution of that application or the job on that data node, and processing and performing operations on the data. So this is how Yarn is structured. Even resource manager here is used to manage all the node managers. It knows which block is being processed by which node manager. Keeps getting the status from the node managers. So the resource manager knows what is happening in each node manager. The MapReduce is the processing capability of the Hadoop cluster, which is a very important piece because we need parallel processing. So, what exactly is MapReduce? It's essentially comprised of two parts, which is the mapping and the reducing. So, mapping stage is where we have a bigger input, and that is broken down into smaller chunks. Those smaller chunks, which are smaller lines of data, are are then processed. And then reducing part is where the process data uh, comes from the mapper. We create a new set of data by the shuffling and then reducing it to form more logically grouped data. So if we see this example, this is a bigger sentence. This got split into smaller lines, which got processed in the mapping stage. So, whatever logic we write, let's say the logic is to break it down into each and every word. So, uh, we have to know that every stage, every mapping and reducing stage, any output of any stage is a key value pair. So, there will always be a key value tuple, as we call it. So, these are the tuples that are generated from the mapping stage. Then it comes to the reducing stage. First, the shuffling happens. The shuffle happens to form understandable view, more grouped view based on the code or the logic that we have written. In this case, we have grouped it based on our key, which is, let's say, the name of the word. So it has been grouped together, and then the reducing part is where it is aggregated based on the logic we write. So the filter and sorting happens in the mapping stage, and the aggregation happens in the reducing stage. So then it got aggregated, and this is the final output, which is a reduced form of the initial sentence we had based on the logic we wrote. So this is the map reduce problem. So now we have covered the essential components of Hadoop. What is Hadoop, and why did we come of a usage of Hadoop? Why did we need Hadoop in the first place? Now, what is HDInsight? We've been talking about Hadoop, but what is HDInsight? So Microsoft Azure HDInsight is a open source analytics service provided by Microsoft Azure in the cloud. So it's a cloud distribution of the Hadoop components. It's fully managed and a full spectrum service in the cloud. So the core components of Hadoop like HDFS, Yarn, MapReduce still remain the same in the HDInsight cluster. On top of that, there are multiple integration capabilities provided by the cluster with different types of clusters: Hadoop cluster, Spark cluster, an ML cluster, interactive query cluster, a Hive cluster. All of these, also it provides support to multiple programming languages. It has default support with Java. It has a lot of on other support with Go, Python, Scala, and any language which is easy to integrate with an Azure HDInsight cluster. So the features of HDInsight are, first, that it is a very low cost cluster. So it makes it easy, fast, and cost effective to produce massive amount of data in a customizable environment. So it's you can pay only for what you use, and the clusters can be created on demand. So it's very low cost. You don't have to maintain the clusters forever. You can leave the clusters when you don't want them. You can take the clusters when you want them. It's an on demand service. Then it has also, in the cost, it has auto scaling features, and it has dynamic allocation features which allow you to not over allocate or under allocate your resources. They allow you to reduce cost by allocating only what is required at a particular time based on your incoming traffic. It is secure and compliant. Azure provides a default security with virtual networks. It provides encryption capabilities, and Azure also has an Azure Active Directory security. Apart from that, there is a component governance and a compliance that is followed for each and every component in Azure. So HD Insight is covered through that. Then it is highly scalable. It's very easy to scale your workload based on the traffic that you are getting. You can scale your clusters. So as we saw, the slave clusters, the data node and the resource manager is what we scale. So we can scale it up and down. It's just by a click of a button, and we can see that in our demo. And optimized components, basically the Azure HD Insight can be extended to be used with various other components, as we have already discussed. It also provides a lot of machine language capabilities for future prediction, and a lot of other capabilities which can be easily integrated in the HD Insight clusters. Now, talking about the benefits of HD Insight over Hadoop, we have mostly covered this. So, what it is low cost because it's an on demand. You can pay on demand for what you need. The cluster creation is automated and is managed from the portal, which is the Azure portal. It also has capabilities with the Azure Monitor, so you can have a monitoring dashboard. You can set up a lot of alerts on top of that. You can monitor using a single interface each and everything of your cluster very easily. You don't need to have an extra setup for the monitoring. The cluster and the hardware as well as the configurations are managed inside your cluster. It has global availability. So HD Insight solution is one of the, it's the only solution that has the availability in maximum regions till now in big data. So it is available in almost all the regions where Azure is available. It also is available in the sovereign clouds, China, the US government, and in Fairfax, which is the Germany. Fairfax is US, and also in the Germany cloud. So then we also have integration, which we have discussed. We can integrate with different databases like Cosmos databases, and we can also have a separate storage in Azure, not only relying on HDFS, but integrating HDFS with the Azure blob storage accounts as well as the Azure data lake storage. So we can decouple the storage from the compute using the different storage and keep our data persistent in a separate storage, so that even if the clusters go down or something happens to the clusters, we can have a storage which is separate from the clusters. Then we have learning and business intelligence capabilities. Here we can have AI tools on top of that. So this is how it is benefited over Hadoop. Now we can discuss something about the different cluster types that HD Insight supports. The first is the Hadoop cluster, which is for the batch processing that we have already discussed. Then there is an H-based cluster, which is written on top of Hadoop, but it is for the unstructured and semi-structured data. It is a NoSQL database built on Hadoop. So if you have a particular requirement of only NoSQL data, we can go for an H-based cluster. Then there's Kafka. Kafka is a streaming platform, and it is also a message queuing platform. So it works as a broker, and it also provides the publisher subscriber model. So if there is a requirement of that, we can go with that. Then there's ML services, which is an R server provided by HD Insight, which is for predictive future modeling. If that is the requirement, we can go for an ML server. Then there's Spark server, which is for the in-memory processing. So it's in-memory parallel processing. If we have a lot of requirement of fast results and in-memory processing, we can go for Spark. Storm is for real-time event processing. A lot of capabilities by Storm are also covered in Spark. Real-time event processing, if that is the only requirement, like for IoT, if you have a real-time event processing, go for Storm. And then interactive query is in-memory caching. It provides a very easy support for BI, business intelligence, with very fast and efficient Hive queries with in-memory caching support. What are the different scenarios where we can use HDInsight? So the basic scenario is an extract, transform, load. So wherever we have a data which we need to transform and then load, we can go for HDInsight. It's for batch processing and data warehousing. So if we see we have a lot of data coming in from our sources, it can come to Apache Hadoop on the HDInsight cluster. We can have a Spark cluster and a Hive and a basically a interactive query cluster. We can use Azure storage and Azure data lake storage as our storage component, and this way the batch processing and the BI capabilities can be introduced in your current processing layout. Then IoT is basically when there's a lot of data coming from different hardwares, from our phones, from our tablets, from our desktops. Then we can actually go for Storm, which we have discussed is for real time processing, and we can use Kafka, which is a streaming platform, or we can also use Spark. So we have a lot of different options to choose from based on our scenarios, and then we can aggregate the data and either show it in a dashboard or send it to another storage or produce different applications of the data. Then there's data science, because HDInsight also provides a ML server, which is an R server. We can use it for predictive future modeling and future trends of a data. If we want to see, based on the current data, if we want to see what is the future trend going to be of the data, we can use this for processing. And then we can have a visualization of that data, or we can send it to Azure Machine Learning itself, which has other tools which can work on that data. Then if you already have an on-premise Hadoop setup and you want to move it to cloud to leverage the cloud capabilities, there is also an option of using express route circuits inside Azure cloud, which can help you moving from your on-premise and integrating it to cloud. So that's the hybrid piece of it, which helps you in integrating and which is also seamless. So now we've seen that HDInsight is basically a good idea, a good way of moving ahead if you have Hadoop requirements or big data processing requirements. And if you want to move to cloud, it's a great solution and very easy to deploy in production. So let's do a demo where we'll be creating a cluster. So this is a Azure portal. If you have an Azure account, we can just simply go to the portal, and in the marketplace we can try to create a Azure HDInsight cluster. So once we go to the option of creating HDInsight cluster, we have a few options to fill. This is the subscription, which is a logical group of our resources. Resource group is a subgroup of the resources. So these are logical entities we just need to fill groupings. So let's say we are doing that. So we can create a cluster. We can put the name of the cluster. And we have different regions. So it is HDInsight is provided in a number of regions. This is the type of cluster like we had discussed. So all these are the types that we have already discussed. We can choose whichever type we want based on the use case we have. So let's say we chose a Spark cluster. Now in Spark cluster, we can choose the different versions based on the availability. So I chose the latest version, and we can give the admin credentials to access the cluster if need be. Also the SSH credentials, which is if you want to log into the Linux machine, you can SSH into the Linux machine. Now we can give the storage capability. We can decide the Azure storage or the data lake that we want. We can have the storage account that we want to link it to. And we can also have additional storage. We can even create more accounts for storage. So then there is encryption capability. We have encryption. We have default encryption, and then we have on top encryptions as well, which we can create if we have a particular scenario of encrypting it. Now after all of that, this is the main piece of it. So in HDInsight terminology, the master nodes are the head nodes and the slave nodes are the worker nodes. So on the head nodes are by default two, and we cannot change the number of the head nodes. One is the primary head node and one is the secondary head node. The worker nodes are the ones which the where the actual processing is going to happen. So this is which what we can scale. So we can increase the number or decrease the number based on the requirements of the workload that we have. So this node size is the SKU of each and every node. We can even decide what SKU we want, how much RAM we want, and how many cores we want of each and every node while the cluster creation itself. So the worker node count can be increased or decreased even after the cluster has been created. And that's just a one-click option. So let's say I give one cluster for now, and these are the different SKUs. I can choose if I need more RAM, less RAM, or anything, and I can have an auto scale capability. So if the workload is increasing, I can allow it to auto scale, and the based on the workload, it can go up and down. And now I'm just creating this cluster. So now the cluster got created. Now moving ahead, how does the cluster look like? So this is how the cluster will be viewed on the Azure portal to us. This is the cluster that we created. The URL of the cluster will be given in the overview section, which is from where we can access the cluster. And as I told you, the Apache Ambari is the UI component, which is where this URL will take us. It will take us to Apache Ambari, which will show us the dashboard of this cluster. So I click on this and it takes me here. So for entering here, there is a security mechanism, which I have already done. So that is not included. The cluster credentials are used to enter and view this. Not everybody can view this. So this is how the Ambari dashboard looks like. So if you see name node, disk usage, CPU usage, how many nodes are live. Since we had only created one node, there is only one data node. How many name nodes are live, all the memory usage statistics, everything is visible on this dashboard. So coming to the statistics for Yarn itself, if we see, we have node manager and the resource manager that we had already discussed. So there is one node manager because we had only one node. So this is how the Yarn dashboard would look like. And now we can have different configurations in Yarn. We can change these configurations. So these are the default configurations. And we can have advanced configurations. We can even include custom configurations based on any particular requirement. We can define the heap sizes. We can do a lot of things with the configuration. So this is one of the ways to add a custom property in the configurations. Coming back to the summary, now we know how we can. So Yarn is basically where the actual job submission happens. So it will know how many applications or jobs got submitted. So this is the dashboard view, which is called the resource manager UI. I directed it to this page, and this is where each and every application that got submitted to Yarn will come. So we can check each and every application status, what happened to that application. If there is something wrong with that application, if it fails somewhere, we can click on that and even get each and every log. So each and every log will comprise of the driver and executor logs. Driver log is the master log and executor log is the slave log. So executor log is the actual log where the processing is happening on each and every slave node. Similarly, since we created a Spark cluster, since we created a Spark cluster, let me just forward it. Okay. Yeah. So I moved to the Spark cluster configurations, and this is the way it looks like. Yeah. Now we can get each and every host information. Okay, sorry again. I think I. Yeah. So this is the piece where we are getting each and every host information. So let me just show you all the hosts in one page. That will be a good view. Yeah. So if we see, these are all the hosts that are available on this particular cluster. So the first two, HN0, HN1, the prefix uh, symbolizes that these are head nodes, the master nodes. One is the primary head node and the other is the secondary head node, which is currently not being used. So the red symbol indicates that this is not being used. And then there is one worker node, since we only created one when we were creating the cluster. Then there are three zookeeper nodes. Zookeeper nodes are basically the configuration service. It allows you to save the configuration information. So these are by default three. So this is how the nodes look like. And then we can go to each and every node and actually check what is running and what is not running on that. So we can see the status of each and everything. So this is how that looks like. Moving ahead, we can see all the different nodes, and we can also have monitoring and alerting support. So based on if there is something that has gone wrong, we can set up alerts. We also already have a lot of alerts enabled. We can even have more alerts. So this is how easily you can view everything from an HDInsight cluster on your dashboard, and how easily it is being used. Now we have come towards the end of our session. I just want to reiterate the key takeaways that we have. First thing we understood is that data is growing tremendously at an exponential rate, and we need optimal processing power to function that data. Hadoop, we have understood, is an efficient distributed framework for the parallel processing and handling concurrent tasks with massive amount of storage capability. HDInsight is a highly scalable and coherent cloud solution provided by Microsoft Azure for big data processing and the storage of data with a lot of integration capabilities. And there is seamless setup for Azure HDInsight, as we just saw. It's very easy to create and very easy for moving from an on-premise solution to a cloud solution if the use case fits there. So that's almost the end of my session. You can reach out to me on my Twitter. You can mail me on my mail ID, and you can also connect with me on my LinkedIn. The slides are present in my GitHub account in this URL. If you are interested, please go ahead and take a screenshot. And there is a joke that I would like to end my session with. So the joke is, why don't keyboards sleep? So uh, I'm not sure if you guys are answering. I cannot see that screen, but let me get to the answer. It's a lame, funny joke because it has two shifts. So a light-hearted end to our session. Thank you for being such a lovely audience. Thanks a lot. Mic drop. So, time for question and answers. If anyone has any questions, feel free to ask me.
Yeah, hi. So, what an amazing session, Niti. Watching the comments, I can say everyone just loved it. And yeah, even I'm saying if any questions are there.
Sure,
Yeah,
that's
okay.
great to know. Yeah.
We have one question from Gaurav Sethia. It asks like, how does map reduce speeds of the process? I did not understand that. I did understand that most of big data applications are based on MR, but not very clear how MR speeds the process.
So the speeding of the process comes with how we are breaking it into different chunks. So if you see, if it is not map reduce, what is happening is we have just one block of data which needs the processing. Map reduce is breaking it down into different chunks so that it can be parallelly processed. So since we are breaking it in the mapping stage, then we can give all of those chunks to different computers, basically the different data nodes and the resource manager nodes that we saw. Each of them can have an individual processing of that data which is not dependent on the other nodes. So the logic that we break it into is important, because then we are breaking the data such a way that each of the data chunk can be processed separately and individually, because we don't want a single computer to be handling that much amount of data. So that is how mapping and then reducing the data to form a logical structure of the data after the mapping has happened. So that is how the process gets speeded up, because we are breaking it down. So it's as simple as breaking it down for different computers to handle it. I hope that answers your question.
Yeah, I guess it definitely does. We have next question. It says how to set Java version in the Azure HD Insight while creating a cluster.
So for Azure HDInsight, you do not need to set the Java version. When you're writing code, so let's say you have a Spark cluster and you want to write code, then at that time, the language you can choose. You can write the code in Java, you can write the code in Scala. There's a lot of good support to these clusters. And when you're writing the code piece of it, you can choose the version what you want. So the cluster version is important. So let's say Spark cluster is the one that I created, then the Spark version is what I will decide. So Java version is not required there. The Spark version is required there. So the Spark comes with like the current Spark version is Spark 2.4. So we can create a Spark 2.4 cluster.
Yeah. So next question is by Tarush, and he asked that are data disks supported within scale sets?
So within scale sets, you can. I'm not exactly sure what data disk is here, but within scale. So when you're scaling the cluster, it's individual nodes. You don't scale the sets entirely. You do not have the visibility of the entire scale sets. It's a individual VM that you are scaling. And let's say you have two VMs today, you can scale it to four VMs, five VMs, and the data is basically the HDFS is integrated in the worker node, basically the worker nodes that you're scaling through the storage capability of Azure itself. So the processing is done by HDFS on those worker nodes.
Awesome. Yeah. So next question is by Sundar, and he asked like, can we use Prometheus for Azure HDI Insights?
I'm not sure about using Prometheus. I've never tried that. I won't have that information. I mean, we can check it. We can just check it online and see if Prometheus is supported. I have not read it anywhere till now.
Okay. Next question again is by Gaurav, and he asks like, as a fresher, do we need to learn about various tools about big data? Example, Apache, Ambari, HBase, etc. As or having knowledge about a small subset is sufficient.
So I would say that we do not need to. We need more horizontal understanding. I don't think it's very much required to know about each and every component. If you want to work on big data, you can pick one component. Let's say you're picking Hadoop and you're going in depth there, that would be sufficient. A basic understanding of the so Apache is just what is a provider. So Apache is providing you with Hadoop, for example. So you can learn about, let's say, Hadoop, HBase, Hive, anything that comes apart from these are on top of this. So if you have information about one of the things, you'll gradually start learning about other things. You do not need to start your horizontal expansion just right now. Try to be more focused on a single thing and then going in depth there and then expanding it horizontally, is what my suggestion would be, my personal suggestion.
Yeah. So next again we have question which says, does each Linux node in an HD Insight Hadoop cluster have its own copy of SSH password?
No, so the SSH is shared across all the nodes. So in one cluster, the SSH will be the same. So the cluster login will be the same. The password will be the same for the head nodes, the worker nodes, as well as the zookeeper nodes. So you can SSH using the same password.
Yeah. Next question asks like, do scale sets work with Azure availability sets?
Azure availability sets and scale sets, yeah, they will work together. Yes.
Okay. Everyone, if you still have more questions, please comment it down in the chat box. And okay, so meanwhile, I guess I can ask one question.
Sure.
How does it stand different from its competitors? Like we have Lakehouse, Databricks Lakehouse platform, Amazon EMR, Cloudera. So how does it stands out and adds a value to the market?
So I think each and everything, the basic idea of each of these will be the same, but there will be some differentiators. For example, the integration capabilities. So with Azure HDInsight, as much as I have used, I've seen it has a lot of integration capabilities. It has a lot of good monitoring facilities, and also on top of that, the best feature which I find here is the dynamic allocation that it allows. So, for example, you have a lot of workload coming in or traffic coming in, you have a setup to dynamically allocate the data based on that workload. So for example, if today you have you have a parallelization of four, which means you are parallelizing the job into four different jobs, and your workload is increasing. So you can, based on a few logics, you can parallelize into eight. And then as soon as the workload reduces and you don't even need the parallelization of four, you can parallelize it into two. So these kind of capabilities are what Azure HD Insight in-house provides, which is just by a click or a configuration. There are some auto scaling capabilities provided, as we just saw. So if we do not need all the worker nodes, we can reduce the worker nodes or we can increase them. So it also is very efficient, cost efficient for us, because we are able to do all those things. And then another very good thing which I find is the monitoring capability, which I have used extensively personally, because if something goes wrong, you immediately want to see what was the statistic, what was the CPU statistic, and that is very helpful with a dashboard in one place, and you don't need anything extra. You can even get all the metrics in your own database, and you can analyze it, write tools, provide any other support on that. So I think there are always some key differentiators. It depends on the use case that you are using. I don't think I would want to sell this as much. Other products might also be very good, but since I've used this more, I feel this is very comfortable to work with.
Yeah, I like the point here, cost effective, as like many small businesses coming into it and starting with the cloud. And when they see like it's cost effective for them, they are more ready towards it. Ki, okay, we can try
Yeah,
it once. Yeah,
right.
okay. We have one more question here. How to send query to Azure HD Insight Spark cluster using .NET?
.NET, I am not sure how will that be supported. Basically, it has a in-house support with Java and Java supported languages. So based on the cluster type, you can use Scala, Go, Python. Scala is basically extension of Java, so you can also use Java. With .NET, there might be some libraries. I'm sure there would be some libraries to integrate that. We will have to search for that. I mean, but I'm pretty sure there would be libraries to integrate .NET with HDInsight.
Yeah. So next question it asks like, does it automatically scale to multiple clusters based on traffic prediction, or we need to use a config file to do the same?
So yes, if we enable the auto scaling, which is while creating the cluster or even after that, we can enable or disable. It's just a checkbox on the portal. You can just choose if you want auto scaling. If you want auto scaling, it'll work on basically two logics: the scheduling capability and the amount of jobs that are in the pending status. So if, let's say, a cluster has 100 jobs that have been submitted to it, and it has a lot of jobs, let's say 50 jobs, then we can choose what capability we want. If we don't want that much job to be in pending state for, let's say, so the default time is 3 minutes. So if till 3 minutes it sees that there is this much amount of job in pending state that we have defined, it will try to scale that cluster. And similarly, scale down the cluster. If till 3 minutes it see there is no job in pending state, it will try to scale down the cluster and then see how it happens. So the scaling is automatic in HDInsight if we enable that property.
We have one more question here. Does Azure HD Insight support autoloader for new file detection?
Uh, can you dwell on this question? A new file detection where and autoloader where? HDInsight is just a cluster capability. The code is separate. So you have to write the code for your jobs to reach that cluster. The code can be written in any of the languages supported. So giving an example, we saw yarn. So how job reach yarn? So HDInsight has a client called Livy. So Livy is a client which sends the jobs to yarn, and we can write code in Scala, Java, or any other language, which will be an HTTP call, which will call Livy, and then Livy will call Yarn. Livy will basically send the request to Yarn, and then Yarn will do all the processing. So the code that we are writing is a separate component. The code is being sent to Livy through the basically through that HTTP call, and then Livy handles everything on the cluster. So if you have more question around that, so basically HDInsight does not have a new file detection there. So that's what the answer is.
Okay, I guess we are done with the questions. I don't see any more in the chat box. Yeah, so thank you so much, Niti. I hope you also enjoyed here and everyone here
Yeah,
joining us today
definitely.
enjoyed it. Uh, so yeah, I hope you all are learning and capturing your favorite moments. As I said earlier, please post them on social media and tag us with hashtag FSS. And next session would be on building E2EE applications by Kevin Nichols and Colin Constable. So stay tuned, people, and take care. Bye bye.
Thank you. Bye bye.